Lesson 11.2. Apply transformations to data. Some of the transformations can be done by adding a constant to the data values. When a constant is added to every value in the data set, the following are true. Well, let's see. If we add the same thing to all the numbers, the average should be changed by the same amount as all the numbers. And if we added something to the number that's the median, it'd still be the middle number. So that number that would be the median still, and the mode, if the same thing was added to all the numbers in the mode, that new number would still be there most often. So the mean, median, and mode of the new data set can be obtained by adding the same constant to the mean, median, and mode of the original data set. And the range and standard deviation are unchanged. Well, think about it. If we range and standard deviation talk about how spread out the data is. If I added the same thing to all the data, it's still spaced apart the same. So it's not spaced out anymore, and it's not closer together. It's still the same spacing. So that's why the range and standard deviation are unchanged. For example, the data below give the weights of 5 people. At the end of a month, each person had lost 3 pounds. Give the mean, median, mode, range, and standard deviation of the starting weights and the weights at the end of the month. Well, to find the mean, I'd have to add those numbers together and divide by the number of numbers. So 138 plus 142 plus 155 plus 140 plus 155 divided by 5. And that gives me a mean of 146. You could also, just like yesterday, put those all into your calculator and have it give you the mean. To find the median, we'd have to put these numbers in order. So let's put the numbers in order. The smallest one is 138, and then 140, and then the 142, and the 155, and then the other 155. So the median, you can see in the middle there, is 142. And the mode is the one that's there most often, so that would be the 155. The range is the largest minus the smallest, so 155 minus 138 is 17. And to get the standard deviation, put it in the calculator just like the last lesson. And it's 7.46. Now, according to our theorem, if we want to have everybody lose 3 pounds, that means we'd be adding a negative 3 to each number in the data set. So that should change our mean, median, and mode by adding a negative 3 or subtracting 3. So the new mean should be 146 minus 3, which is 143. The new median would be 142 minus 3, which is 139. The new mode is 155 minus 3, which is 152. This can be found by taking our numbers and subtracting 3. So if I subtract 3 from 138, it'd be 135. 3 from 140 would be 137. This would be 139. 152. So just subtracting 3 from each of these. And so we can see our median, the middle number, is here, 139. And the mode, the most common, is the 152. And if you find the mean of those 5 numbers, you should get 143. The range is still the biggest number minus the smallest number, so 152 minus 135 is still 17. It's unchanged. And the standard deviation still hasn't changed. Still 7.46. We could also multiply the data values by a constant. Consider the set 1, 2, 3. By multiplying by 10, I'll get 10, 20, and 30. For the top set, the 1, 2, and 3, the mean would be 2. Add them together, get 6 divided by 3 is 2. On the bottom set, the mean is 20. Add them together, divide by 3, you get 20. Notice the median on the top set is 2, and down below would be 20. There's no mode neither. But notice they're multiplied by, each of the central tendencies are multiplied by 10. For dispersion, between the 3 and the 1, for the range, 3 minus 1 is 2. The range on the bottom, 30 minus 10 is 20. Again, it's multiplied by 10. And the standard deviation, the average distance from the middle, is 1. 3 is 1 space from the 2, 1 is 1 space from the 2. Down below, it's 10. 30 is 10 spaces from the 20. 10 is 10 spaces from the 20. So all the measures have been multiplied by 10. So when each value of a data set is multiplied by a positive constant, the new mean, median, mode, range, and standard deviation can be found by multiplying each of the original statistics by the same constant. Going back to our weights, we had these numbers from the previous example. The mean, again, can be found by adding these up and dividing by the number of numbers. The median is when I put it in order. The median is this one in the middle, 142. The mode is the one that's there most often, the 155. The range is the greatest minus the smallest, 155 minus 138 is 17, and the standard deviation was found by putting those numbers in my calculator. To change it to kilograms, you would multiply by 0.45. So I take my mean and multiply by 0.45, and the new mean in kilograms, 65.7. New median be 63.9. New mode be 69.75. New range, and new standard deviation. So you get all of those by multiplying by the 0.45, which is what you convert by changing the pounds to kilograms. The other way is you could take your 5 data values, the 138, the 140, the 142, 165, and multiply those by 0.45 to get the original weights in kilograms, and then find the mean, median, mode, range, and standard deviation. That would just take long.